Good afternoon, everyone, and welcome to our webinar about free flow tooling. My name is Nathalie, and I take care of everything that concerns marketing and communication within MAC. We are thrilled to see that you guys are here today. And before we get started, I would like to say that we will definitely foresee a Q&A at the end of the presentation, where all your questions will be answered. But in the meantime, feel free during the webinar to already ask your questions in the Q&A box below. You'll find it in your Zoom screen below. I'm sure my colleague Pierre can't wait to guide you all through our free flow tolling solution. So Pierre, the word is yours.
Yes, thank you very much, Nathalie. So my name is Pierre Boutene, International Business Developer at MAC. And today, as Nathalie told you guys, I'm going to give a bit more information on our solution, how we see free flow tolling going into the future, and how we as a technology company and expert in mobility can help companies providing the mobility or the free flow tolling solutions of tomorrow. Before starting on the topic itself, I will give a very short 20-second introduction about our company for the people who are new here. And thank you all for joining, of course. So MAC is a Belgium-based company founded in 1923. So today, almost a century ago, actually. We are the third generation. We are with a team of over 130 people, mainly engineers. And we have been developing smart mobility solutions and smart cameras since 2001, so more than 20 years today. And therefore, of course, we have a lot of expertise. And that's also what we want to show and explain you today a bit more in detail. So we are active in mainly two areas, business areas, mainly smart mobility and ITS, of course, and also automation. So let's start now with the topic of the webinar of today. So before starting on the topic, I will explain you a bit further how the webinar will go. So I will first of all explain a bit how we see the free flow tolling solutions of tomorrow. Afterwards, I will explain how we can help as MAC providing such solutions on the hardware side. Besides that, we will also, or I will also discuss a bit our software solutions related to free flow tolling. And then at the end, I will also explain a very new solutions that we have that comes actually in the very beginning of free flow tolling, and that's connecting OBU data to number plates, etc. So if you look to free flow tolling today, here you have two examples of the more well-known free flow tolling solutions. So on the left-hand side, you see the standard tolling gates with barriers where most of the cars need to stop, pay for their ticket, and then they can drive freely on that tolling road. On the right-hand side, you see the free flow tolling gates, so the gantries, with, as you see on this picture, quite a lot of equipment, going from ANPR cameras to radars, to detectors of OBU data, to lasers, extra infrared illumination, and so on. So a very complex solution that can take some time to integrate, but also has quite a high maintenance cost, and therefore not to be underestimated. We as MAC see the solution or the future of free flow tolling more on the side of using less equipment, and equipment that is capable of detecting more than only one sensor was capable of doing in the past. So how do we see this? So we see, for example, here we see an example of this, where you have a gantry with just 3 cameras connected, but cameras that have AI embedded and can do almost all the stuff that you could do before, but now with only 3 simple cameras. So on the side, on the hardware and software, how do we see this? So we have a range of AI cameras that you can see over here, going from our QCam3 to the QCam5 to the QCam7. And the big difference here, and that's quite important to elaborate on, is that the cameras do not work anymore as older cameras or normal ANPR cameras used to work. So the biggest difference here is that those cameras have NVIDIA CPU and GPUs integrated, and therefore they first of all always detect an object. Once they have detected an object, then they will check if the object is a vehicle. If so, they will check all the characteristics of the vehicle. But otherwise, the camera will also be able to detect other types of objects, for example. I'm not going to explain completely today how the cameras work. This is going to be for another webinar, but we see the future in free flow tolling with cameras that have AI embedded and can do almost everything, but then just with one sensor actually. So for example, the QCam5, here you see some metadata that the camera can register. So you see that the camera just with images and of course with the video flow, it can register the number plate of a car, the country code of a car, the classification, going from, for example, a passenger guide, a car to a light truck, heavy truck, bus, van, motorcycle, and so on and so on. But the camera can also do mark model recognition. So for example, Renault Megane can detect the color of an object or a car, vehicle, can detect in which lane the vehicle is driving, at which direction, what the speed is of the vehicle and the timing and so on. So the camera can almost detect all the data that is needed to be able to go to a high-end free flow solution. And that's quite interesting, of course, as you need less equipment, but you do have the same output. So therefore, this is quite an interesting solution that is very future-proof, of course. So our goal in the free flow tolling area is, first of all, with our equipment, reduce the point of failures, as there is less equipment needed, as the equipment only gets stronger and more capable of detecting multiple aspects of the free flow tolling solution. Reduce, of course, the maintenance that is needed, and reduce, therefore, also the overall cost. The second point is, of course, that we work on to be able to deliver highly accurate data. Therefore, we have a lot of algorithms that compare different data models with each other to always have the best capable data outcome. We also work with reliability rates and so on and so on, all therefore to be able to have a highly accurate system. And of course, we want to deliver a future-proof solution. Our cameras or our equipment, our sensors can also be completely remote updated due to the fact that they have GPUs and CPUs that are very powerful integrated. They can, of course, also change quite a lot in the future, depending on how software algorithms are evolving. We are able to deliver a more future-proof solution every time that we have made some enhancements. Now I will show you some examples of the camera installed, both on a sideway installation as on a gantry installation. And there you will see the flow of the camera itself. So this is what the camera does actually. So everything is integrated into the camera. Everything is done on the camera level itself. And this is what you are going to see. So you are going to see the video stream of the camera itself with the processing of the camera directly done on the camera itself, so not on a server side. So here, for example, you can see we detected a truck. You can see all the specifications of the truck. Here we see a van. We have classified it as a van, number plate, make, model, speed, direction, and so on and so on. So you can see that the vehicles are quite far in the image, but due to our algorithms, due to the resolutions that we are capable of using and also capable of processing on, so not only using to send to the customer, but also to really process on, for example, 3.2, 5, or 12 megapixel. We are capable of doing quite impressive recognitions on. As you can here see, for example, this vehicle is quite far on the third lane from the camera, but we had no problem detecting it. Of course, depending of what the customer needs, we can of course use multiple cameras on multiple angles or have cameras in parallel with each other that work together with each other to have the best outcome of data possible. A second possibility is, of course, the gantry installation. Again, here we have one camera for 3 lanes. This could also be one camera for 1 lane, depending on the angle and depending on the lens that we use. Or, for example, this could be one camera for 2 lanes and in total 2 cameras, so that every lane is covered 2 times, and that we can check with the back office which data is the best, and then give the best outcome, of course. So here you see a video of the live stream of what the camera is detecting immediately with the bounding boxes, showing that we do object detection. Here you can see the black and white and color images. And if we zoom in a bit, the number plate is now blurred for privacy reasons, but if we zoom in, you will see a part of the number plate here. You can see that, again, it's very, very clear, very sharp. And then, of course, there are all parameters that can be done in the camera itself. Again, for reducing the maintenance cost, we have decided to enable a remote pan and tilt motor inside the camera itself. So again, our goal is always to reduce the overall maintenance cost, overall implementation cost, to make it as interesting as possible for the client. And here you can see an example of this. If we then go a bit further into the camera specifications, you can see here some examples of night images. What's important here is that you see very well the number plate, and second of all, that you see very well the vehicle contours and the vehicle itself. This is only with the integrated infrared illumination of the camera itself. No other infrared illuminators are used here, or no public lighting is available at this site. Here you can see some other examples. And then if we go to elaborate on that example, we can see the metadata on the right side, and you can see that we detected that this was a MAN TGS heavy truck. So we did mark, model, and classification at night without any problem, with a confidence level of 98, 96, and 99.9%. So that's very interesting, of course. If you then go to the backend, so on the first side, on the sides, you will have all your sensors, your cameras, maybe also detectors for OBU and so on. But on the backend, of course, you need to detect and handle all that data. So also, therefore, we have a solution which we call our InCube solution, which stands for Mac Mobility, Mac Mobility Manager software. So, and this is a data centralization software that gathers the data of all your sensors that are on different sites. It can be 10, 100, or even thousands of sensors. And the system is completely open, easy to integrate, which also gives the possibility to connect other types of sensors that are also not MAC sensors. So we can gather data from, for example, OBU data sets with our camera data set, and make sure that all this data is connected with each other to the finalized metadata and output data. It's also important to say that it's a scalable and reliable solution. It has the horizontal scalability behind, and therefore you can scale it very easily depending on the amount of sensors, the amount of users, and so on. And of course, it's a system that can be run locally on a server, but can also be run on the cloud very easily, for example, on the Amazon cloud system. So it's a very easy system, and you can access it via your PC, mobile phone, tablet, and so on. If we then go to the last topic of this webinar, so as I mentioned at the beginning, we also have something new. It's quite interesting, and we wanted to already give a very short introduction into it in this webinar, is the OBU digitalization. So we have seen that a lot of our clients, or a lot of companies, are struggling a bit with the digitalization of connecting OBU data to number plates and to the exact truck. So we recently have worked on a solution where we can digitalize the entire process to equip trucks with OBUs. Before our solution, the companies needed to manually write down the number of the OBU, manually write down the number plate, then go to their backend system, manual fill it in. And this day in, day out, every day for hundreds of thousands of trucks every year. So it was a lot of work. So we decided to develop a solution, actually a mobile app, that enables OCR recognition. So for the number plate, but also for the OBU serial number, and that can be automatically or that can automatically send the data to the backend system of that client. So the first goal is, of course, recognition of the European license plates plus the country code. Once this is detected with the app, you can then recognize the serial number on the LCD screen of the OBU. This is then via an API sent to the backend system of the client, the company, and then this is automatically connected and automatically registered. So it's a complete digitalized flow where customers can really easily do the entire flow without needing to do everything manually with paper and so on. This is, for example, an example of a mobile application that we have developed where you can scan your number plate with, see all the characteristics of that number plate and that vehicle, and also go into history and so on. So it can also, of course, be used for other projects, of course, but this one was a very interesting one, of course. And besides that, it's also quite important to mention that the entire algorithm of the OCR is running on the app itself, so not in the cloud. So which means that if you would not have any mobile connection, not any internet connection, then it would also work perfectly, and then everything would be synchronized, of course, once you are connected to the internet. So this was mainly the slide and the presentation. Thank you all for listening. I think now we can go together with Natalie a bit more into the Q&A session if some people have some questions.
Exactly, Pierre. Thank you for the presentation. I thought it was really interesting. And while you were presenting, a few people posed some questions. Let me start with the first one from Nuno. Sensor numbers also depend on country legislation. Example given, some countries demand front and rear LPN. Would one camera per lane in this case be sufficient?
So yeah, it's a very interesting question, of course. What we showed is an example of how how the cameras can be equipped. Of course, if you need front and rear number plates with pictures and so on, you will, of course, need to detect the front and the rear number plate, and therefore you will need to have, of course, two cameras. Of course, depending on what the need is and reliability rates and so on. You could, for example, if there are only 2 lanes or 3 lanes, you could, for example, use one camera for the front detection for the 3 lanes and one camera for the detection of the back number plates for the 3 lanes also, which means you would have 2 cameras for, in theory, 6 lanes, 3 on the frontal view, 3 on the back view. This is a possibility. Of course, depending on the specific specifications, could be possible also that you need more cameras, but theoretically and how I show it in the examples, this could be done with 2 cameras.
Okay, next question. Customers require high availability solutions. How would your solution of 1 camera per lane satisfy this requirement?
Yeah, again, an interesting question. So our cameras, so first of all, to start the question, we have been in the business since 2001, so we know the ANPR business very well. We have worked in Belgium in the beginning, which is one of the most difficult, or in Europe, one of the most difficult number plates to detect due to contrast aspects, due to the character that are used in Belgium and so on. And so therefore we gained a lot of experience. And then last year we have elaborated on that and go more into the European and worldwide market. And we see that with the current algorithms that we have developed and that we are still maintaining and always optimizing, and with the image quality that we have, which is very, very high, we are capable of doing very precise recognitions that are very powerful. Depending again on how high the performance needs to be, there are possibilities where you will use 2 cameras, as I explained, for example, 3 lanes, where certain cameras will double detect a certain lane to have a double check of every lane to be able to, or to be sure that the number plate is well detected. Every number plate and every character is analyzed one by one, but it's very important so that we give a very well reliability rate. The reliability rate is actually for every character itself. And if we see that a certain character has a low reliability rate, we can of course know that this character will probably not be right. Then we can go and check it on the second camera. And then if there we have a high reliability rate with another character, we can combine those 2 and see and finally get the right number plate. But this is completely automatically. But depending on what the exact requirements are, this could be a possibility.
Okay, thank you. Another question also from Nuno, is the Cam5 solution detecting width and height of the vehicles?
So at the moment, the camera is not detecting the width and the height of the vehicles. However, as we can do mark and model recognition, and we can also connect our complete system to open data platforms, for example, in Netherlands, like the RDW. We can quite easily get this on that side. And also, as we know mark and model, and we did the mark and model completely on a visual recognition, we can of course also connect this and say, of course, that this vehicle has this width and this height standard. If you want to have it exactly for every vehicle, not connected to mark and model, this is something that is still not available on the camera, but that could be available in the future, as we also do speed detection. And for speed, we also know the length, or we do estimations on the length of the vehicle and so on. So this could be an upcoming feature.
There was also someone wondering, what are the differences between the 3 cameras you presented?
Yeah, so as I presented in one of the first slides, I presented QCam3, QCam5, and QCam7. The 3 of them are completely different, but are based on the same AI protocols and AI backend systems. But the difference is some features, but also, for example, different lenses, different sensors. So it are 3 different cameras, but they are all supporting the AI system. But this is going to come in the next webinar. So in the next coming webinar, we will explain completely in detail what the 3 cameras have from specifications, for which application every camera can be the best used, and how the cameras work step by step.
How many countries does the solution support? Are metadata gathered from vehicle registration systems?
Yeah, so the solution, so if it is on the OCR side, we support almost any country in the world. So we have implemented our solutions, for example, in Australia. We have implemented them everywhere, or in quite a lot of countries in Europe, but also, for example, in Vietnam, Brazil, US, and so on. So we can cover the OCR part almost on every country in the world. Of course, depending on where we are, we need to have a learning curve. But due to the AI again, this can be quite easily done and on a short base.
Then Thomas Schulz is asking, how do you manage new vehicle types? Does the camera have to be updated regularly with vehicle databases?
So it depends on what are the what is the need of the camera, of course. In theory, if you would connect our CAM5 to our backend solution, so our MCube solution, and the MCube solution is connected to a vehicle database, for example, in the Netherlands, RDW, Belgium, DV, or some other examples, then if we see a new Markend model on the backend side via the back office, we could, of course, start learning the cameras that this type of image is that type of Markend model recognition. In practice, we do indeed sometimes, mainly 1 or 2 times a year, an update to be able to cover those new Markend model recognitions. But on most sides, it's quite not that often that this will happen, and our camera can also detect the year of the Markend model. So therefore, it's quite complementary, but indeed, it's a good question.
And then Victor Lepage is interested in the clouding solution. Could you be a bit more specific about it?
Yeah, so the MCube, the Mac Mobility Manager software suite, is a software suite that can be very easily set up on a, for example, on a cloud solution that is, for example, the Amazon cloud system. And then everything is running on the cloud, which means that you don't need your local servers anymore. You can very easily integrate it in your current system. And what's more important, of course, then is that you can very easily access, of course, depending on your privacy settings and so on, but you can very easily set up the complete back office solution and access the back office solution from a mobile phone. But as this is a very complete product with a lot of specifications, a lot of capabilities, you can always contact us directly if you have more questions about the MCube, or visit our website, of course, as we there also explain a bit more how the solution works, and which component it uses, and for what application it can be used, because it can not only be used for example, free flow tolling, but it can also be used for low emission zones. It can also be used for blacklisting and so on.
And then we're up to the final 2 questions, Pierre. How do you correlate information collected from multiple independent sensors?
Yeah, so if we want to use multiple sensors, and that's of course something that we have done quite a lot in the past, we send the data from those sensors to the MCube back office system. There, the metadata is gathered together. Then some processes are being done to be able to have the right metadata and the right analyses, and then this is shown to the user.
Okay, and the last question, as the cameras are using artificial intelligence, can they also detect other objects than vehicles?
Yes, indeed. So the camera can also detect other objects, which could also be interesting to see, for example, a bicycle, a person, so a pedestrian and so on. So all those types of objects, but there are a lot of more objects that we can actually detect. So this is also quite interesting and quite interesting for the future, that we can do those things. It also means that we can detect vehicles without number plates and alert this.
Definitely. And then if you want to go to the next slides, to close off, I wanted to tell you all that this webinar is being recorded as well. We're used to putting our webinars online. All the recordings are able for you to watch on our website in the menu webinars. The next webinars we have in March, it's about our complete QCAM series, and in April about smart parking and our AI box. So please make sure to rewatch and share our webinar if you want, and to register for the next one. And I want to thank you all for coming and for joining, and hope to see you next time.
Yeah, thank you very much, everybody, for joining. Have a good day.
Bye.